We're going to solve this problem in the interval 0 to 2 pi. We've got the cosine squared of theta equals 1. Now, using algebra, we only have one term that has a trig function in it, one angle, which is theta. Our problem here is that we have squared. So we know how to solve when we've got an x squared. We square root both sides, and we're going to do the same thing here. But when we square root both sides, we're going to have a plus or minus. So we have the cosine of theta equals plus or minus 1. That means that the cosine of theta could equal positive 1. The cosine of theta could equal negative 1. And in the interval from 0 to 2 pi, 0 all the way around to 2 pi, we know that the cosine of theta will equal positive 1 on the positive x-axis, and it will equal negative 1. There's our ordered pairs on the negative x-axis. So our angle on the negative x-axis at negative 1 comma 0 is pi, and on the positive x-axis it's 0 and it's 2 pi. But notice how 2 pi has an open interval. The reason why 2 pi is an open interval right here is because we're only going to count that location once, and when we count it, we're going to count it as 0 radians. So our answer here is theta equals 0 radians and theta equals pi radians. Two answers, 0 and pi. Let's try another where we've got that exponent of 2 on our trig function. 3 minus 2 sine squared of theta is equal to 2 sine squared of theta. Now we have sines in both of our terms, and we have the same angle. So I'm going to attempt to use some algebra techniques of adding 2 sine squared of theta to both sides so I can get the trig function on a side all by itself. These actually combine to be 4 sine squared of theta. Now I want to isolate that sine squared of theta, so I'm going to divide both sides by 4, and I get 3 over 4 equals sine squared of theta. Now I'm ready to square root both sides, and when I do that, I have a plus or minus. So we have plus or minus the square root of 3 over 2 is equal to the sine of theta. Well, when I draw my quadrants, this is a pi over 3 angle, 1/2 square root of 3 over 2. And we want both positive answers. So here's our positive answers. That's going to be pi over 3 and 2 pi over 3. So theta equals pi over 3 and 2 pi over 3. And then we also want the ordered pairs where the square root of 3 over 2 is negative. And that's going to be 4 pi over 3 and 5 pi over 3. So our negative values will give us angles of 4 pi over 3 and 5 pi over 3. So basically, long story short, is because we have this plus or minus, we're going to have the pi over 3 angles in all 4 quadrants. That would be pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Now we're finally going to get to an example where we have 2 different trig functions. Actually, not quite yet, I guess. We've got, actually yes, right here. We've got 2 different trig functions, but we do have the same angle. So we have cosine squared of theta equals sine of theta plus sine squared of theta. Now, the problem here is that we've got cosine and we've got sine. The good news is that they're all the same angle. Another piece of good news is that we know how to substitute an expression in for cosine squared in terms of sine. Remember that cosine squared of theta is equal to 1 minus sine squared of theta from our Pythagorean identity. Sine squared plus cosine squared equals 1. So I'm going to substitute in 1 minus sine squared of theta first cosine squared of theta. Now I have 4 terms, but 3 of the trig terms all have the same trig function of sine. So I'm going to set this equal to 0, and this is where my zero product property is going to come into play. Remember, the zero product property says if you have factors and their product is 0, then one of the factors must be 0 to make that true. So I'm going to add sine squared over, and I'm going to subtract 1. When I do that, I'm going to get 2 sine squared of theta plus sine of theta minus 1. Now, I'll show you real quick. Add sine squared over. There's your 2 sine squared of theta. Subtract 1, and you get 2 sine squared of theta plus sine of theta minus 1. Now, this is factorable into 2 binomials. We've got 2 sine of theta times sine of theta. That's going to get us back to 2 sine squared of theta. And then we have 1 times 1, but one of them is going to be positive and one of them is going to be negative. We want a positive sine of theta, so we're going to make this positive so that we have 2 sine of theta. We'll make this other one negative, so that's a negative sine of theta. Positive 2 minus 1 is positive 1. We're going to use the zero product property. 2 sine of theta minus 1 equals 0. Sine of theta plus 1 equals 0. The sine of theta equals 1/2. That's going to happen in quadrants 1 and 2, and that's going to happen at a pi over 6 angle. So the pi over 6 angle is pi over 6 in quadrant 1 and 5 pi over 6 in quadrant 2. Here we have the sine of theta equals negative 1. The sine of theta is negative 1 at 3 pi over 2. So sine of theta equals 1/2 gave us pi over 6 and 5 pi over 6, and sine of theta equals negative 1 gave us 3 pi over 2. Now this was asking for solutions in the interval 0 to 2 pi, and all 3 of those angles are in that interval. Let's move that answer over here. Okay, here's another. We have 3 cosine squared of theta equals 4 cosine of theta plus sine squared of theta minus 2. Now, you might feel comfortable trying this one on your own. I say give it a shot. It's very much like the last one. You just have to decide whether or not you're going to have everything in sine squared or cosine squared. Okay, if you paused and you're back, I'm going to reveal the technique, the strategy. The strategy here is I've got cosine that's quadratic, I've got cosine that's linear, and then we have sine that's quadratic. It's easier to change the sine squared of theta into cosine squared of theta than it is to change these 2 terms to sine. So that's what we're going to do. We're going to change sine squared of theta into 1 minus cosine squared of theta. So we have 4 cosine of theta plus 1 minus cosine squared of theta minus 2. That's on the right hand side, and then we have 3 cosine squared of theta on the left. I'm going to move everything to the left hand side so that my quadratic term has a positive coefficient of 4. I'm going to subtract 4 cosine of theta from both sides. 1 minus 2 is negative 1. I'm going to add that to the other side, and we get 4 cosine squared of theta minus 4 cosine of theta plus 1 equals 0. And now it's time to factor. 2 cosine of theta, 2 cosine of theta. We're going to make that minus 1 and minus 1. That is going to give us an outer of negative 2 cosine of theta an inner of negative 2 cosine of theta, which gives us that negative 4 cosine of theta. This is our factored form. 2 cosine of theta equals 1. 2 cosine of theta equals 1. It's the same solution, so we're going to have a multiplicity. We've got cosine of theta equals 1/2. This is in the interval from 0 to 2 pi, so we know we want quadrant 1 and quadrant 2. 1/2 for cosine is going to be a pi over 3 angle, so we want the pi over 3 angle in quadrant 1 and the pi over 3 angle in quadrant 4. I said 2 and I meant 4, and I think you knew I meant 4. I hope you knew that I meant 4. I don't know why I said 2. It's definitely 4. Pi over 3 and 5 pi over 3 are our solutions.